Okay, so have a think about what we have learned last lesson this Tuesday. We talk about maximum turning point, minimum turning point, stationary point of inflection, and also tell you what is absolute minimum and absolute maximum. So sometimes the endpoints can actually higher than the turning points, so that one will be the real maximum value. And then the turning point is about that area, that is the maximum. Okay, that is the maximum. And how do we find stationary points? So maximum, local maximum, local minimum, and stationary point of inflection, they all called stationary points. So how do we find stationary points? Is we use f dash x equals to 0 and we solve for x. Because f dash x equals to 0 means the tangent of the gradient equals to 0. And for those three type of graph, yes, we do have a horizontal tangent and they have gradient equals to 0. So after we solve it, we just solve out, like, for example, three values. We don't know how to, we don't know whether they are maximum, minimum, or stationary point of inflection. Then we introduce this table to test about it. Okay, how this table works is the first row is the x or t or whatever variable values, and the next one is the f dash x value. So this case, you have dp dt. And as I said, according to VCAR report, you must have values in the second line. Make sure you can do it, not you just guess it. So we have substitute, like we choose, first of all, we set up the table, like we make the stationary points in the middle and have two empty columns to the left and the right. And then we choose values. Okay, for example, negative a third. I'll choose a value smaller than that, which is negative 1. And I'll choose a value in between negative a third and 2. And I choose 0. And then a value greater than 2, I choose 3. I sub that into the derivative function. I find like 12, negative 4, and 20. Therefore, I know the shape of the graph. That's a graph, looks like that. That's how do we find the turning point. That's how we find the turning point of a polynomial. Because the turning point is no longer exist in the middle of 2x-intercept, and therefore, we use derivative equals to 0 to find the turning point. And that's what basically we have learned last lesson. Have a look at example 2. We just use this fact. Okay, the curve with equation y equals to x cubed plus a times x squared plus bx plus c is 3 unknowns. Okay, passes through the point 0, 5. Okay, what's the 0, 5 tells you? Like, knowing the graph is passing through that point, what you can say about this graph? Like ABC values, like
C is 5.
C is 5 because when x equals to 0, y equals to 5. So therefore, C equals to 5. Okay, that's the last constant value. Okay, and with a stationary points 2, 7, what you can talk about?
Gradient equals 0. The gradient equals 0.
Gradient equals to 0. So what's the gradient? No, I mean, what's the expression for gradient?
F dash x equals 0. I mean,
at which point? Like f dash x can't equals to 0 for anywhere.
F dash.
Yeah, f dash 2 equals to 0. The gradient at x equals to 2 will be 0. But don't forget, like, it's a coordinate that the graph passing through. This point is no difference compared to the point 0, 5. It's just another point on the curve as well. So f2 equals to 7. Stationary points gives you two pieces of information. One piece of information just as normal. You sub that into the original graph. And then you have like 2, 7. And then stationary tells you the gradient equals to 0. You can have f dash 2 equals to 0 as well. Well, I shouldn't say f dash 2. It will be dy dx at x equals to 2. But that's fine. Let's find f2. What's f2? f2 is 8 plus 4a plus 2b plus c. C is 5. That is 0. That's f2 equal, not 0, 7. That's f2, not f dash 2. So what you have is 4a plus 2b equals to 7 minus 13. That side is 13, so you have a minus 6. So 2a plus b equals to minus 3. Okay, that's from f2 equals to 7. f2 equals to 7. And and f dash 2 equals to 0. Oh, nice shape. So straight. Okay. Okay, f dash is dy dx. Okay, dy dx equals to 3x squared plus 2ax plus b. 3x squared plus 2ax plus b. Okay, that's dy dx. So at x equals to 2, dy dx will be 0. So what I will know is for 12. 12 plus 2, 4a plus b equals to 0. So I can have 4a plus b is negative 12. So how do you solve that? Yeah, simultaneous equations. I use first top one, subtract the bottom one. I'll have minus 2a equals 2 minus 3 minus negative 12 is plus 12. That's 9. That's 9. And a equals to negative 9 on 2. So b will equals to negative 3 minus 2a. That's minus 2a. b is minus 3 plus 18. And b is 15. Is that correct? It seems correct for me. Wait. 9. Yeah. That's 9. Sorry, that's a 9 and that's a 6, and that looks better. 9, 6. Yep, 6. Good. So we have that, and that. Yep. Okay, next one. Next one, okay. I want to introduce one thing. That is actually the kinematics part, which the part we skipped for chapter 16 and last chapter 17. I think we skipped the kinematics part. So I want to give you need to know one thing. You know displacement, right? Everyone understand what's displacement? Displacement is if I start here, okay, after a while, it doesn't matter what takes me in between. I finish, for example, over there. I stand over there. So during that period of time, my displacement will be the starting point distance to the finish point. So that is my displacement. And regardless what happens in between, I can walk like fast like this way for 10 times and then finish here. But my displacement is still from here to here. Okay, so displacement is just where is the start point, where is the finish point. You use the final position, subtract the initial position. That's the displacement. But like, that's not what I want to say. I want to say is, for example, that's the displacement graph. The displacement x meters of a particle moving in straight lines is given by that function. So this is a displacement time graph. Okay, xt is called the displacement time graph. A good thing to displacement time graph is if I differentiate that. Okay, if I differentiate that. Differentiation means find the gradient, right? Find the gradient. But I don't want to actually find the gradient. This one, like if the graph with a meaning, xt is the displacement time graph. If I differentiate, that will become the velocity time graph. Okay, that's the good thing about it. That gives you the velocity at any time. Yes, it's still the gradient of the function, but it's also the velocity time graph. It can tell you what's the time and what's the velocity. So that's something important. You must know that. Okay, yesterday the teacher who write the paper said like students better know that. I know we skip that, but like the teacher says we better know this function like for the test. So that's something, it will be appear on your test, I believe. So displacement time graph, derivative ones, that will become velocity time graph. That gives you the velocity at every time, okay, anytime. So I can sub 1, 2, 3 in. It is also the tangent function, like gradient of the tangent, but it's also the meaning is the velocity and time. Okay, that's all I want to say for the kinematics part. You just need to know that. The placement axiometers is given by that function from 0 to 3 root 3. Where t in seconds is the time taken. Find the maximum displacement. Okay, tell your time yourself 10 times. Anytime you see a question asking maximum or minimum, asking you maximum or minimum, you solve it by making derivative equals to 0. Okay, this is the typical type. Like in VCAT exam, you always been asked maximum or minimum question. It doesn't matter what type of equation you have, what kind of things you have. When you see the word maximum and minimum, 99% of the chance you need to do it through derivative equals to 0. Because why derivative equals to 0? That will gives you a turning point. Okay, you can find a turning point. Well, whether it's a stationary point of inflection or minimum or maximum turning point, it depends on the function. But most of the time, it will be done by sketching by derivative equals to 0. So most of the time will be derivative equals to 0. So this is maximum. I still have year 12 students when they see a maximum graph and tell me, I can't sketch that. How can I do it as a sketch? Not sketch, you making derivative equals to 0. That's the way we solve for it. Maximum and minimum, they solve by the same method. I'll tell you what we do after that. So maximum, minimum, we solve it by dy dx equals to 0. You will try that. Maybe one question out of 100 questions may not be solved by this method, but like it wants you to start from that and try that. Well, 99 questions, you can do it. Okay, that's enough. So what I want is derivative equals to 0. What I'll have is dx dt equals to 0. So dx dt is 9 minus t squared equals to 0. Well, t is plus minus 3. T squared equals to 9 and t is plus minus 3. And because t is greater than is that. So t is 3. Okay, you haven't shown that is a maximum or minimum point. You just, what you have solved out so far is derivative equals to 0. It can be a maximum point, can be a minimum point, can be a stationary point of inflection. You hasn't shown anything that's a maximum. We need to use the table after that. Okay, we need to use the table method after that. So we will draw a table. Okay, the table will look like x dx dt. No, this one should be t, not x, because t is your independent variable. So t dx dt and then graph. So what you would do is, we have 3 here. Well, let's select a 2 here and a 4 here. When x equals to t equals to 3, dx dt will be 0. That's what we solved. And when we have 2, we put 2 into that. I will have 4, 5. And put 4 in that, 16. Minus 7. Okay, you dx dt dx, can't write, dx dt equals to 9 minus t squared. You put t into dx dt to find out the value. So the graph is increasing, 0 and decreasing. So at 3, it is a maximum point. So that is 3, comma, you put 3 in, x equal, well, t equals to 3, x equals to 27 minus 9. X is 18. Okay, 3 and 18. You put 3, you have 27 and 9. So at time equals to 3, and then maximum displacement will be 18. Because can you see that's a turning point, and then nothing will be larger than that. Nothing will be larger than that. So that is the maximum point. So find the maximum displacement. So x max equals to 18. It's not enough you just work out the t value. You need to also find out the x value. Okay, that's the maximum displacement. And remember, the derivative of displacement time graph will be the velocity time graph. Okay, derivative of displacement time graph will be the velocity time graph. For example, that question, v will just be 9 minus t squared. V will just be 9 minus t squared. That's the vt graph. It tells you all the velocity, okay, at any time. And it is also the tangent of the gradient of the tangent for the xt graph. Any questions about this one? No? Okay. If not, let's do example 4. Okay, example 4 says, find the stationary points and state their nature. So find stationary points, what we need to do. How do we find stationary points? Equals to 0. So f dash x equals to 9x squared minus 4. And 9x squared minus 4 equals to 0. X squared equals to 4 on 9. X equals to plus minus 2 over 3. So we will sketch that. First one is the x value, and here is f dash x, and here is graph. The first one is empty. Second one will be negative 2 and 3 in order from the smallest to the largest. Then 2 and 3 next, and then another one. Okay, what value you choose for that? Well, here we have 0 and 0 for sure. F dash x is 0 and 0 for sure. Okay, what do you want to choose here? Here. Ah, good. Negative 1. Here? 0 and 1. Okay, easy to calculate. We put that into the f dash x function. What we have is 1, negative 1 squared, 1, 9 minus 4, 5. I put 1 in, that is 5 as well. I put 0 in, that's negative 4. Increasing, 0, decreasing, 0, increasing. The shape of graph is that. I know that point. That point is negative 2 on 3, comma, and that point is 2 on 3, comma, I need to calculate. Okay, f 2 on 3. That's 3 times 8 over 27. 3 times 3 is 9. 3 times 9 is 27. So 8 on 27 minus 4 times 2 on 3 plus 1. Here is that's 8 over 9 minus, that's 8 over 3. So 16 over 9 plus 9 over 9. 17, 8, 16, 1 over 9. Right? 8 minus 16 minus 8. Minus 8 plus 9. 1. So it's 1 over 9. And f negative 2 on 3. That's negative 3 times 8 over 27 plus 2 on 3 times 4. 8 over 3 plus 1. That's 9. That's 1. That's negative 8 over 9 plus. Oh, wait. I think I make a mistake here. No. Okay. 8. And this 2 times 3. That's a 24. Right? 8 over 3. 24 over 9. And this 2 times 3. Okay, right. And that will be 17, 24 minus 7 on 9. Okay, minus 7 on 9. That's minus 16. And then minus 7. Yeah. And then minus 8 on 9 plus that plus that. So that's a 25 over 9. 25 over 9. So we have this point here. The 0 must be in between. Okay, the 0 must, if asked me, the next question is asked me to sketch graph. So the y-axis must be here. And then the intersection is 1. So the x-axis must be here. So that's approximately the shape. Okay, approximately the shape. I'm not guaranteed, but like it will be roughly what it looks like. So I know what is the maximum minimum turning point looks like now. What I want to know is the x-intercept. Why sketch graph? I can find the turning point, I can find x-intercept and the y-intercept. So I can see 3 x-intercept here. I can see 3 x-intercept here. So how can we find x-intercept? Yeah, fx equals to 0. So 3x cubed minus 4x plus 1 equals to 0. How do we solve for it? Yep. Yeah, x minus 1. Is that 1? Yep. X minus 1. 3 minus 4 plus 1, yes, 0. So x minus 1 is a factor. And what do we need? But like if you can't see it, like the table method works for you, or long division is fine as well. So we have 1, 3, and 0, minus 4, and 1. I've tried 1, so 3, minus 1, and 0. So it is a factor, and then 3, negative 1 is the other coefficient. So 3x squared plus 3x minus 1. Can I keep factorizing that? Well, I don't need to really factorize it. What I can do is x equals to 1, or 3x squared plus 3x minus 1 equals to 0. So x equals to minus b plus minus, don't forget your quadratic formula. Okay, b squared minus 4ac is a plus 12 over 2a. That's a 6. Inside is a 21. Okay, inside is a 21. So that's these 3 x-intercept. Okay, that's the 3x-intercept. So if I'm sketching this graph, okay, first value is 0, 1, about here. Okay, that's the y-intercept. And I can have negative 2/3. And then that one. It's about here. And the minimum one is quite symmetrical here. And then negative, less than negative 1 is approximately here. And those 2 points is negative that, 25/9. This point is 2 on 3, negative 7 on 9. Okay, x-intercept, I have 1, 0. Okay, which is here. 1, 0. And then I have those two values. Okay, so root 21 is in between 4 and 5. Okay, it's in between 4 and 5. So negative 3 minus 4 is negative 7. Negative 7 divided by 6 is negative 6 on 7. Okay, negative 6 on 7. Negative 5, negative 8. Negative 8 is negative 4 on 3. So 1 point, well, it's about 1 point something. Okay, 1 point something, 1.2, 1.1, negative 1.1 is somewhere here. That's the negative one. And you have another positive one approximately here. Okay, so the shape of the graph will be okay, the shape is roughly like that. Will be pretty much the same as the top. So that value is negative 3 minus root 21 over 6, 0, and that one is negative 3 plus root 21 over 6, 0. Okay, you need to label all the x-intercept, all the turning point, and okay, nothing else. Well, if you have stationary point inflection, you need to label that. If you have endpoints, you need to label endpoints. But like we don't have that in this graph, so that's all. I have a question. This is a, okay, who said that? You answer my question, okay? You answer that. So the question is, I have a new function, it's called gx. Gx is fx, is just this graph, plus a value c. Okay, plus a constant c, constant. So my question is, what c should be to make gx has only one x-intercept? Okay, that question is a VCAL question. It's exactly a VCAL question, and VCAL like this question. Always ask it. I know it's a little bit hard for year 11, but you need to think about now, because no one will really teach you this question until you do the practice exam. So I see a good example, so I just bring it up to you. You have a think. This is not part of the course, it's just something you need to understand, you need to think. So no textbook can really show this question to you. So have a think. Basically, I have this fx graph. I'm moving it up or down. Up or down. I have 3 x-intercept for fx. So how much I need to move up or move down? I will have only 1.
Is there anything more than 7?
Question, answer?
Is there anything more than 7 or 9?
Moving up greater, you mean c is greater than
7 or 9.
7 or 9? Yes, that's, you move it up. So you move the turning point until the turning point go up to the, well, you moving up the graph is the same as you moving down the x-axis. So if you move it to here, well, like exactly here, let's say here, then you only have 2. Then you just keep moving a little bit higher, like greater than that. So you only have 1, but it's not all of the information. Not all answers. You have another part as well. You only consider moving up.
Yeah, you could move it down.
How much you need to move it down?
20. Anything more than 25.
Anything more than 25 or 9. But C, how do you describe C?
C is.
Yes, you have the correct idea. Moving down for that much units at least. So what C can be? C is R. It doesn't say C is positive or negative. C can be negative values. C, well, C is negative 25 on 9. What the sign will be here? What sign you put here? Equal, greater, less, less equal, greater, equal.
Oh yeah, no, it's less. Wait, what? I'm now confused.
You want to make
Oh, yeah, it's
the
less because then the negative.
you want to make the number even smaller. You want to make an even smaller number, so you want it less. So you move more than that much. So as long as C is negative, you are moving down the graph. So how much you want to move down? You want to move it down until 25 on 9. So you want to move more down. So that's make the x-axis about here. Okay, make the x-axis, new x-axis about here. Then this graph only have 1 intercepts. Okay, only 1 intercepts. And then that can give you only 1 intercept. So this answer should be a union. Okay, C should be that set, union that set. You need to have both answers, either this or that. Okay, you can move up or you can move down. It's 2 different values. Okay, so this is not that difficult. This question is not that difficult. You just need to think about the movement about the graph. You need to realize C is a constant. It decides how much the graph going up or down. Students most of the time can think about the positive one, like moving up, but they never think about the moving down part. So C can be negative. So C can be less than a negative number to make it moving down. So you need to include both values here. Okay, so you will meet a lot of questions next year about that, and I was just let you know this is about moving up, moving down, and it's about the turning point. You do it when with the turning point. Okay, this is a better one. Like the harder one will be how much I need to move to make it only 1 negative or 1 positive intercept. Like I want 1 negative or 1 positive intercept. How much I need to move? That will be the harder part. X-intercept question. So I'm not going to talk about that hard one yet. So make sure you understand that one. That's an important question. So it combines with that perfectly. So you need to find the turning point of the polynomials and decide the movement. Okay, the next question I'm talking about is also very important. It's VCOM multiple choice question. I'm not sure if you I didn't really see it in the short answer, but it's always in the multiple choice. Okay, always. Sketch the graph of a function with rule y equals to fx, given that f1 is 32, f5 is 0, f0 is 25, f dash x equals to 0, when x equals to 1 and 5. So what you know is f dash 1 equals to f dash 5, and that equals to 0. you know f dash x smaller than 0 when your x is in between that. Okay, that's one condition. And you know it's greater than 0 when it's greater than 1 or less than 5. Less than 1 or greater than 5. Less than 1 or greater than 5. So this is the type of question. Okay, I summarize this type as sketch fx by using the information of f dash x. Okay, can you see it actually talks about a lot about the f dash x, what the f dash x will be with 1, with 5, what the f dash x will be with greater than 1, greater than 5, or in between 1 and 5. It talk about f dash x a lot. So this question will be done by table. Okay, by table. The table can only test the nature of the point. It can also help you to sketch fx. So I have x, f dash x, and the graph. First empty, second one you have 1, empty, have 5, and that. Okay, because why I make 1 and 5 there? Because 1 and 5 are the stationary points. Agree? Because f dash x is 0. I know f dash x is 0 at 1 and 5. So 0 and 0. The next thing I know is when x is in between 1 and 5, the gradient is negative. So I have negative value here. Well, I don't know what x give what negative value, but I know that any value in between 1 and 5 will be negative gradient. And any value less than 1, greater than 5 will have gradient positive. So I have positive for that two box. Yeah, that's what I know. So overall, I have positive, 0, negative, 0, and positive. I have a graph like that, according to what they give to us. Okay, according to what they give to us. So I can have a shape like that. Okay, this point is 1 comma something. This point is 5 comma something. So let's have a look. It passed through 132. So here is 32. And pass through 5, 0. Okay, that's 5, 0. And I also have 0, 25. Well, I don't care 0, 25 yet. Because you have 1 here. So your 0 must be here. The y-axis must be here. And the x-axis must be here because 5, 0. That must be x-axis, that must be your y-axis, and you also know that that point is 0, 25. It's given in the question, 0, 25. Okay, so that's the shape of the graph. According to the information gives to us, I can sketch the shape of the graph like that. Well, I can't find the other x-intercept. I think it's not given. No, it's not given. I can't find the other x-intercept, but that's fine. Yeah, that's fine. Maybe we can work it out. I can make y equals to a, x minus b, x minus 5 squared and substitute the 0, 25 and 132 in it, I can solve out A and B values. Well, I'm not going to do that. I know you don't want. But I just tell you you can, okay? That's something possible. So, yes. You can sub 0, 25, 132, and you find the value of A and B. Alright, I will finish today. Tomorrow I have 2 more pages to go.